Alrighty, let's take a look at this question. So we're asked to complete the square to write each quadratic equation in the form x plus p bracket squared equals q. Now I'm going to carry that further because really the purpose of doing that would be so that we could then solve for x. So I'll show you why we even write it in that form. And I'm going to choose to do C, which I think is one of the harder ones there. We have the equation 1/2 x squared minus 3x plus 5 equals 0. Now normally if you're asked to solve a quadratic equation, you would try to factor it. I'm thinking maybe that doesn't work out so well on this one. Let me think, if we multiplied everything by 2, we'd have, yeah, it doesn't factor. So that means completing the square would be an option. The other option is use quadratic formula, which is essentially developed by completing the square. But here we go. So completing the square, we want it to look like this, x plus p bracket squared. So we have to have a trinomial that can be factored into a perfect square binomial. So first thing I would probably do is do it just like we did with quadratic functions. So we're going to underline these two x terms, and we want to factor out whatever's in front of x squared, because when we write that factor, we don't see anything in front of x. Okay, so 1/2 gets factored out, so that would leave x squared. And then we factor it out of -3, which means we're dividing. So -3 divided by 1/2 would be the same as -3 times 2 over 1, so that should equal -3 times 2, so -6x. Leave a little room because we want to create the perfect square binomial from this trinomial, plus 5 on the outside. And I'm going to skip the equals 0. I'm going to put a little more room there. So plus 5, put equals 0 over here. You could move the 5 to the other side as well, but I'm trying to do the same method as we did for quadratic functions. All right, now we need to come up with this missing term in here that would cause this to be a perfect square binomial when factored. And to get that number, we basically take the coefficient of the x, so -6, and we divide that by 2, and then we square that number. So -6 divided by 2, -3, and then we square -3 to get +9. So we add 9 there. Maybe I'll do that in red. And because we can't just willy-nilly add 9 to an equation, we have to keep it in balance by subtracting 9 times, look at that, 1/2 was actually outside the bracket, so it was being multiplied by the 9 was being multiplied by 1/2, so we got to also multiply by 1/2 when we take it away. All right, looking good. Keep the 1/2. We're going to factor x squared minus 6x plus 9, and it will always be the same two factors because we designed it to be that way. So we're just going to simply square root the x squared to get x. Use the same sign as the middle term, so minus from the -6, and then square root the +9 to get 3, and there we go. That's that factored. Outside here we've got plus 5 minus 9 over 2. Lovely numbers. Okay, let's simplify that a bit more. We'll need a common denominator. Should be 10 over 2 minus 9 over 2 would be +1 over 2. Oh, actually, that's going to work out okay. So we're almost there. They wanted just x plus p squared. So we need to move this 1/2 that's being added to the other side by subtracting. So we'll have 1/2 bracket x minus 3 bracket squared equals -1/2. And then we are going to divide both sides by 1/2. And we will have x minus 3 bracket squared equals -1. All right, well, I was going to say I was going to solve this for you. However, the next step in solving it, if we were actually trying to, so first of all, this is what they want for the answer. We're done. But if we were trying to solve it, we would then square root both sides of this equation. However, you may notice that square rooting -1 doesn't work out so well in the real number system. So that's really as far as you could go. But if you could, you would do that, and then you'd have basically two equations, x minus 3 equals plus or minus whatever that number is, which in this case doesn't exist, and then you would add 3 to both sides. And you would have your two solutions, one with positive, the square root, plus 3, and then one with negative, the square root of whatever it was, plus 3. Alrighty, so that's kind of completing the square for the purpose of possibly solving this quadratic equation for x because we couldn't factor it. Alrighty, hope that helped.